Thanks everybody for coming today. We're pretty much going to be going over how to perform whitebox pen testing. Specifically, we're going to be looking into more or less some of the methodologies on how to find better vulnerabilities, sort of what my approach is when looking for different vulnerabilities in web applications. A little bit about the code itself, understanding a lot of the weird things that can happen in a particular coding language, and then we'll briefly go over some of the tools that you should probably study up on if you're going to be doing any sort of web app pen testing. So typically, it's pretty much what I just said, right? We got three things that we're going to go through: methodology, coding, and tools. And so let's just jump right into the methodology. There'll be a couple demos today. I'll pass the source code out after the demonstration if you guys want to play with it as well. It won't have the database file, but it should be okay. So essentially, whenever you're doing white box pen testing, which is a mix between I want to say gray box approach. So you have the source code to review the application, as well as pretty much do whatever you want with, right? If you can get the database set up, 9 times out of 10, you can run the source code for a web application just fine. Sometimes it'll use cloud resources. That's a little trickier to set up locally, but ultimately, you have the opportunity to set the application up. Whereas with black box pen testing, you don't have a whole lot of opportunities to build anything out, and typically the methodology goes like this for the black box, right? So you're given an endpoint, and you're usually given this endpoint by a client or somebody you're doing work for or whatever it may be. You're basically given an endpoint, whether it's a hack the box client, could be anything, could be any endpoint. So for the example that I'm going to use in this methodology, we can start with Google, but like I said, it can be anything. So really the first step, you get the endpoint. Second step, you got to find everything, right? It's a black box pen test. You don't really know where anything is. You may be able to quickly find some of the endpoints using Burp Suite or FUF or any of the other tools, but the reality is that you have to perform quite a bit of fuzzing to actually find a lot of the endpoints. And even when you find a lot of the endpoints, the reality is you probably didn't find any of them, or all of them, not any of them. But since you haven't found all of them, you want to fuzz everything that you possibly can, find as many endpoints as you can, and sort of work from there. So after you fuzz it, find a bunch of endpoints, then you're going to map your endpoints and order them by risk. And when I say map out your endpoints, I'm going to show you this map. So I have an Excel document that I use whenever I'm doing any sort of app pen tests. Can you guys see Excel okay? Let me zoom it up here. Just a quick yes or no.
Yep.
Yeah.
Cool. All right, so for a web application penetration test, it usually starts off like this, right? So I have my map, I set my map up for a specific client, and like I said, I fuzz everything. I find every valid endpoint that I can do, every possible method that I could do it with. I don't always put like what parameters the endpoint does, but when I get a bunch of crap where it's like user 1, user 15, user whatever, a lot of times I'll get that with tenants where like every time I click on a different object, it just gives me a bunch of garbage. So I'll take those out, I'll sort it up, and essentially I get what looks like this. So for a very light example, we have a application, let's just call it Google. It has a login, a logout profile, and you can get different users and user IDs. So essentially what you do is you start from the top and you go, okay, where's the risk here? What's the more or less like the risk-based assessment? If login and logout are done by using a third party like like a OAuth login or like a any sort of like proprietary somebody else built it type deal and you just integrate it and it works. Usually I'll put those as very low risk because the chances of those having a big vulnerability in them are not very high. The developers can really mess up in the implementation of them, but like actually putting them in and like developing them, you don't often get a whole lot like that. But where you can get a lot of vulnerabilities is usually like when you can post data to a user type deal, right? And so a lot of the vulnerabilities pop up when, if the user has a bunch of parameters, including, let's say, a name, a home website, and stuff like that. Maybe we get the user's ID by performing a curl request on their website or whatever, right? Could be any vulnerability, but essentially, you'll map out what's your OWASP top 10. These are a little bit old. These are the big ones that I find and look for, which is why I keep these here, whether they're old or not. But yeah, so going forward, if you want to update these, change them to what your priorities are, feel free to do that. But essentially, you'll go through, you go, okay, I looked at it. It looks really funky on the post of the login, so I want to follow that up, and there may be an injection. There may be, let's say, like a OTC in the login, if it's not implemented by somebody else usually. But it's pretty much what you want to do in terms of just mapping it out. You can order these based on risk as well. So if you wanted this one to be, let's say, like the highest risk, you could add like a column here for risks and then put whatever risk score that you want. The problem with doing risks one by one and not just eyeballing it is it takes quite a while to put like a risk score for every single endpoint. Depending on what the client wants or depending on what you want to do, sometimes it may be useful for longer engagements, but typically I don't have a whole lot of time to look at these different web applications and such. So this is pretty much where I get started with this. There's another version here with the entire OWASP. Same scenario, endpoints followed up. If you looked at it, and then every single vulnerability that you could think of. And this makes it super simple whenever you're doing any sort of report writing. You already know what you need to write up. So I have a, OTC vulns here, here, and here. And so I'll have one finding for OTC, and I'll list these 3 endpoints and what they did wrong and how they did it wrong, and why it's systemic throughout multiple layers. And then you can do that for pretty much any of them. But this is what I do typically when I map out a application, which is usually the third thing I'll do in a black box methodology. The fourth thing, obviously, perform your testing. OW10 is OWASP top 10, so try to find as many vulnerabilities as you can. Most of them will be on the OWASP top 10. A lot of times you'll get some weird deserialization, a lot of access control issues, things like that. And I think we have one more after this, but a pretty important thing that a lot of people do and wait towards the end, and it's not very good, is more or less like report writing and note-taking type deal. It's 100,000 billion bajillion times better to do your report writing and taking your notes and everything like that while you're doing it. The reason I say that is because a lot of times the applications may change while you're testing them. I know it's not ideal. It's never ideal. But the reality is that things are always progressing. Things are always changing. Things are always moving. So you'll have developers a lot of times where they're pushing code, they're updating things, and then your application suddenly changes, and this cool critical vulnerability that you thought you once had is now gone. And if you didn't take the notes, if you didn't document it well, the chances of you using that finding in the report are pretty much zero, especially if you can't replicate it. So big tip, big advice, gradually update your reports and spreadsheets and do it as you go. Don't wait till the end. And then the last one, as always, write a pretty report. Hope your client approves it. Depending on what you're doing, if it's a hack the box, it's still good to get some experience doing report writing, and then you can always go through those. Pretend like your buddies or executives or engineers or whatever, and sort of set the tone and talk through the report with them. That'll really help people get up to date in terms of, or up to speed in terms of public speaking. But yeah, so far, do we have any questions, comments? You guys, while we're going through this, feel free to shout out, jump in, ask questions, anything like that as well. Okie dokie. Take that as no questions, and I went the wrong way. So this is sort of where we get into the difference, right? So for a white box approach, it's sort of a mix between gray box, black box, and actually doing straight source code review. So for the white box approach, it pretty much starts the same way a little bit, but you are given access to additional things. So you're still given your endpoint. In our example, it's Google, but additionally, you're given GitHub, you're given the source code, and a lot of times, which is probably the best thing anyways, you're given access to the engineers who actually wrote the code. So whenever you're doing any sort of debugging or trying to go through what the code is doing, how it works, if you can't understand how it works, just ask the engineer who wrote it. And 9 times out of 10, they'll explain it to you. They're really happy somebody's looking at their code and trying to figure it out, and it's complex, and they don't even really understand it fully, and it's a whole lot of fun. But yeah, essentially we start the same way. And then in a white box approach, we take it a little bit different. We don't have to fuzz everything because usually when we fuzz the application, we don't even find anything. We don't find everything to begin with. So instead, in a white box approach, what you want to do is you want to review the source code. You'll still map out your endpoints. And specifically, you'll map out the endpoints as they are in the source code, not as you found them in Burp or whatever else. In Burp, I forgot to mention this on the black box approach, but with Burp, you can actually just copy and paste the list of URLs that are in there, and it'll print out perfectly to Excel, which is really nice. But essentially, so as you're going through your source code, you're going through your web application, if it's PHP, if it's JavaScript, doesn't really matter what it is, you'll be able to find your endpoints, GET requests, POST requests, updates, deletes, options sometimes. And so you'll want to map out all the endpoints that you can possibly find. And so after you're done doing that, you start reviewing some of the functionality, and typically, you kind of want to take notes on two different things. You want to take note on the functionality that you can't find natively on the web application itself. So this could be things like, the back end on how it updates a file on the local system, right? You may not have access to any sort of like code injection or anything like that, but it may be very interesting to see what it's actually doing when it's performing any sort of operations in the back end. You also want to take note on functionality that's not being used. So like, usually with that, it's like various different options. So if you have two paths that you can possibly take on like on a chart or node chart, and you can't really see the second path, maybe it's in development, maybe it's just, legacy code, you may be able to see it in the source code and then access it that way as well. So on to number 3, right? Look for custom features. So for the example I gave before, if a customer or a client decides to roll their own authentication into an application, 9 times out of 10 they're probably going to screw that up. If you're using something that's public, it's really well known. It's very easy to implement it. And it's the chances of you screwing up the implement are not very high. Whereas if you try to roll your own authentication where you're trying to custom create the encryption and all the keys and do key mapping, and it just becomes this huge problem where it's just so wrong and it breaks every single way, and it's just terrible. So look for stuff like that. Look for custom features, anything that looks like very out of the box. It's always good to take notes of those. All right, number 4, and this one's pretty important. Also my favorite thing to do, and which is why I pretty much only like doing white box pen testing anymore, is try to spin up the application on your own, especially locally. A lot of times it's a little bit difficult just because you'll need, like a temporary database. You may need some sort of like S3 buckets, maybe some cloud servers. But essentially, if you can get some of it spun up locally, it's 100 times better than just reviewing the source code. It gives you the option to do things like debugging, adding print statements in random places. You really get to see the intricacies in the back end of it. And if you need to do logging, if you need to do extra print statements, if you need to see how something is really working, spinning it up locally is what you want to do there. Cool. So another big thing, especially when you're doing any sort of source code review, take notes within the source code itself. The problem that I often see is people will take very small notes in the source code. So whether that be on the same line, of something that they're looking for, or like maybe if they're doing like a little note on top of a function, like, oh, this might return this, or this might be a problem. A lot of times when you're going back through a really large code base, it's impossible to find any of your notes. So what I do is I'll put a custom identifier on it. So I'll put, MK : and then whatever the note is. And then I'll make it really big. I'll put a lot of pound symbols. I'll just make it as visible as possible within the code base. That way, if I ever really need to go back and find something, it's pretty easy to do so. And this is the local code, right? This is the source code that's provided. Don't do this in like a a GitHub environment or something where it can't be undone. Last but not least on the methodology for this is finding vulnerabilities, right? You want to be able to get all these cool critical vulnerabilities, profit. When you can collaborate with the source code, I know collaborating is usually with people, but if you can collaborate with the source code and use it to aid you when you're trying to look for these vulnerabilities, especially doing things like debugging, putting custom error codes in there, trying to print out different statements to see what items are being compared, that'll help you find 1,000 more vulnerabilities than trying to throw things at the wall or do fuzzing or anything like that. So yeah, that's pretty much all I had on the methodology stuff. What questions do you guys have for me?
I got a cool thing to talk about. It's not really a question, but so I was working on a pen test with a coworker, and my coworker got fucked over because he didn't back up his log files in Burp. His Burp instant crashed, and he lost all his logs. And he found a really cool auth bypass vulnerability where when he bypassed the authentication, we actually found dumps of an old pen test from a competitor. So it was a really cool finding, but because he lost the logs, they kind of dismissed it. So always back up your shit.
Yeah, that's a great point. I've seen that happen way too many times. Even with your notes, I always keep a set of notes local, and then every night my local notes are pushed to the cloud. But
So as far as like rehosting, I guess another person's code, I mean, I'd imagine like you'd be able to work with the developer to kind of better understand how to launch that. But do you have generally a method you follow to setting up something that you don't know? Like, do you use like maybe a Docker infrastructure or like certain types of VMs or something to usually get those running quicker than having to sit there and debug somebody else's launch script for like 10 days or something?
yeah, so typically what I like to do is I'll ask them, what do you natively run your web application in? Do you natively run it on like a Linux machine? I have had some customers that run their entire web application infrastructure on a Mac. I'm like, okie dokie. And some that run it on Windows. So usually that's like the big question that you always want to ask, and you can do that before the engagement even starts. And most people, if you just email them and ask them, like they'll just be like, yeah, it just runs so much smoother on Linux or on Mac or whatever it may be. So I'll pretty much start with developing like a virtual machine with that. I personally like virtual machines a lot better. I feel like I have a lot more visibility on what's going on within it, especially with like the GUI or if I need to use VMware tools to drag and drop files. I just prefer it. I know of a lot of people that use Docker for that as well. Docker's great, especially for smaller projects. For bigger projects, it's kind of tough unless you're sharing like folders back and forth, which can be a little tough as well. But with the virtual machines, I'll just install my tools on the virtual machine. I typically start with trying to find where their data sources are stored. So if they're storing it in like a hard coded on the disk itself, it's usually easy to set up that way. But the reality is most people don't do it like that. Most people have like a database, whether it's a NoSQL, whether it's MySQL, SQLite, whatever it may be, right? So I'll work on the database first, getting that set up and kind of matched to their architecture. I always ask if they have like a testing environment that they use, because typically if I can get the database for any of that test code, I'll throw that on there and work with that locally. And then, yeah, like you said, working with the developers is going to be your best bet. A lot of times they'll actually, in the GitHub repos or whatever they share with you in the source code, they'll provide instructions in, like a README or whatnot on how to build it out, which is really nice, or how to get it set up. A lot of times that won't include database information, so how to get the database set up, but overall it's pretty, I don't want to say seamless, but I've had pretty good experience with it. Some engagements it just doesn't work. You can't host it on your own, and it is what it is when that happens. But yeah, that's typically my approach for it.
Okay, makes sense. And I kind of had another question too with, I guess, whitebox testing, you're not dealing with anything compiled or a front-facing interface. So you're dealing with the code usually, and the code can vary greatly depending on projects that you're working on. Is there kind of like a catch-all solution you use to kind of catch yourself up to speed with whatever language they might be using? Or do you tend to just kind of, just go for the docs? So if it's like PHP, you don't know PHP, just go read PHP docs. And then I guess a follow-up to that would be, how would you figure out what's known as like bad code for that language if you're not familiar with it?
So before you get into any sort of situation where you're professionally reviewing source code, if you don't know the language, you're going to have a hell of a time trying to figure out what most of the things do. There's an old fool's tale, not a wise tale, a fool's tale that says if you can read and write one programming language, you can read and write in all of them. And the fact of the matter is, it's just not true. A lot of times with syntaxes or anything like that, there's just so many oddities with different programming languages. So typically my approach, if I'm trying to just learn a new language in general, I'll usually start reading through the docs, building out some test programs. I'll try to apply it to something I'm working on at the time. And this is just personally how I'd start learning different languages. So, for example, like if I wanted to learn Nim, the programming language, and I would sort of apply it to a project. So whether that's building out a C2, whether that's building like a to-do bot, or anything like that. And if I wanted to learn Swift, for example, I'd build out like an app that tells me the time in Russia or whatever. So personally, I always apply things to something else because I tend to remember things a lot better and just learn things faster when it's applied towards a project. In terms of figuring out the weird stuff with the language, there's not a catch-all to do that. Just because it takes more time and experience to learn more about what the language is doing, how a lot of different things work. Programming languages can be very, very different, especially when if you're trying to compare like a Java to a Lisp, they're not even remotely close. So there's never going to be a catch-all. If you're doing any sort of source code review, I highly recommend that you understand the language pretty well before you do it, because if you don't, you're really going to struggle to find a lot of the good vulnerabilities that are there. And I'll sort of go back to the presentation to branch off of that as well. The coding part, what Nathan brought up, like that's a huge thing. If you don't understand the language that you're coding in, you're just not going to be able to get a lot of the good vulnerabilities or even understand what the code is doing really. And so it kind of brings me to the second point in the talk, which is you got to know your shit when it comes to reading and writing the code in whatever language it is to do better on any sort of white box test. So I don't know why I did that, but so for web apps specifically, like the big three you should know HTML. I think everybody knows HTML at this point. CSS is important, but like you don't have to be an expert in knowing how different styles work or how it any of that sort of stuff. But the two you do really want to know for web apps is JavaScript and PHP are really the big two that I see nowadays. Knowing a backend is always great. Knowing like a quick scripting language is the best thing in the world. But like the reality is like nobody can know every single language. So try your best and then pick one that you want to work on. If you're really interested in web apps and you like doing web app security, you should know JavaScript and PHP at a minimum. And so that sort of brings me into my second point. So more or less, like today, I'll show you guys a pretty cool source code example that I made. And this is going to be in PHP. PHP is one of my favorite languages for any sort of web applications. There's a lot of different intricate vulnerabilities with PHP where it's PHP specific. There is a few other languages that do a lot of the things that PHP does, but these are really, really odd things. And so without further ado, let's jump into the demo a little bit. Let me close out of that. And Cool. All right, so we have the source code as well, but we're gonna start with a web application. Okay, so or no, we're gonna start with the source code. So we have a web application. It's just running a PHP web application on port 80, and essentially what it does is we have two files. We have a forgot file and we have a reset file, and I pretty much just map this off of something I've seen pretty recently in the past, and I thought it was just a very unique vulnerability. It's very specific to PHP, so let's sort of dive into what it's doing. So we'll start with the forgot password. So it takes a parameter called name. This is just our database connection stuff. I wouldn't worry about that. But essentially what we're doing is we are resetting the user's password. And so when we reset the user's password, what we are doing is we are getting their user ID, we're getting the current time, and then we are creating a pin. And so this pin, I know this looks kind of bizarre. Essentially what it is it's a random 7-character or 8-character string. So for example, this pin could be 0 through 8, I suppose. That'd be the easiest one. Or it could be or we can add strings in here, or different characters or whatever. So all this is it's creating a random MD5 hash and then just taking a substring of that, which is the first characters, which seemed like the easiest way to do this at the time. But from there, what it's doing is it's submitting a query to the database, it's updating our user, and it's updating our reset pin. We also can see that it's updating the reset at, and it's putting in a specific time. So let's go give this a shot. I found one error in the code right now, but I'm just not going to mention it. So our username is Nightbane. So if we send a forgot.php to Nightbane, we get a message back saying reset link for user Night. Cool. All right, so we essentially get this, right? So we got a email from our local system administrator that gave us our reset token password. And so with this password, we can go and do this. Just open it up in a new tab. We can go do this, and it says, woohoo, you are logged in as Nightbane. And we can sort of see like the little bit of the structure here in the token. And this is what some people will do if they're rolling their own, like a forgot password thing. So if we jump back into the source code, we can see that our reset link, or our token at least, comes with a few things. It comes with our user ID, which is the first value. It comes with our PIN, which is the second value, and it comes with the current time we reset it at, which is the third value. So to find the vulnerability here, we sort of need to see how the reset password works. So this is where we're actually submitting our token, essentially calling this, right? So what we're doing is we get a token, that's the parameter token, as you can see at the top there. With token, we connect to our database. Don't worry about that one. And let's just move this back over here. And so we're doing basically one thing, right? So if we can successfully log in to the website as whatever account we provide, we need to basically get two operations correct. We need our PIN to match exactly with the reset PIN that's provided. The reset PIN that's in the database and is completely random, and it's the 8-character PIN. We also need the time to match up. So if we look at this at more or less like a high level, this is what the database looks like. We only have our 3 users. We got admin, Nightbane, and Pascal, and then some emails for them. Their passwords are just plain text right now. Usually these will show up as SHA 256 or whatever when they're hashed, just so you guys can kind of see what it looks like unhashed. I tossed them in here. So, and obviously none of these words are on Rocky. We're not really going to be able to crack these. So more or less what we'll want to do is we'll want to take a whitebox approach. And so we'll look at our forgot password and we'll look at a few things. So the things that we know or could at least guess on, is our user ID and the time. We won't have any idea what this pin is because it's randomly generated every time we reset the password. So if we look right now, let me close out of that one. So if we reset it again, we go into our database, we refresh, we see that our reset at time was changed and our reset at pin was changed as well. So since these two values changed, they're not predictable. At least the time is predictable. The reset pin is not predictable. We will have no idea what this reset pin is, right? So sort of working with that, let's go back to our code. So we know two things, right? We know our user ID and we know our time for the token. And so since we know those two things and we don't know our pin, essentially what it comes down to is you can brute force this. That's actually, I think I have a slide for that actually. So we can brute force it, but brute forcing it would require I had some guys do the math on this one. So about 3.5 billion, 1 in 3.52 billion would be your chances of brute forcing the alphanumeric pin. Which isn't very high. Is it possible? Sure. But is it probable? Nah, not really. So what we want to do is we really want to limit those odds. So we can see here that we're doing we're trying to match the pin that's provided by the token itself. So this is user provided, and we're matching that with the pin in the database. So this is kind of, before I go down the rabbit hole a little bit too much. So what we're doing if this was a Python, like a compare in Python, we would be checking the value of pin to whatever we queried. These will bring back a string and a string, and then we're checking if these strings are exactly the same, if those match. In PHP, this is where knowing the weird intricacies of PHP comes in. This is called a loose comparison in PHP. So with loose comparisons, we're not actually comparing the straight value. So for example, if we had, let's say, an integer 000, if we are trying to check if that's equal to 0, this will come back as true. I know it seems very weird, and we have a little chart for that as well. But essentially, this is what the loose comparisons look like in PHP. So that's using the double equal sign, right? So if we say, is the string 1 equal to the Boolean true, that'll return a true. Very bizarre. It does happen. And then if we also have a false, right? So if we say false, that's equal to an array. That returns a true value. So PHP is just very odd in terms of essentially in terms of just what a loose comparison is. It's not just PHP. I believe there's another language that does this as well. But essentially, if you can get any of these to match up or find a loose comparison in PHP, then ultimately we may be able to bypass this a little bit. So we're not going to be able to get fully through it, but we can kind of cheat a little bit. So we know that with the forgot.php, which is here, we know that we can essentially re-roll whatever this pin is every single time. So more or less what we want to do, and I'll show sort of an example of this as well. So with a loose comparison, if we have any value, any string value that's, let's say, I think that's 7 characters, about 7 characters long, and we say, is this equal to, somebody want to give me a random number real quick? Just 4-digit?
1272.
1272. Cool. So if we said, are these two equal to each other, do you guys know what would be returned here? Or do you guys want to take a guess? True or false? Anybody?
True.
True. Yep. And that is, so this is just one of the weird oddities on how, because it's a number, whether it has a string, I believe you can do it with a string in there as well. Maybe not. But since they're both numbers, essentially what we're doing is we're trying to roll the dice and land on a good number. So we're going to cheat a little bit, and we're going to change it to, somebody want to give me another 5-digit number?
1337, or yeah, sorry, 31337. There we go.
Okay, cool.
Yeah.
Cool. So we'll save this value in the database. The chances of us rolling this are possible. Probable, maybe not. But, if we have the opportunity to send as many forgot password requests as we possibly can, then it's easily probable. And so the one thing that we will know, in the database at least, I guess we can kind of guess what our ID will be. But we can tell, with Burp Suite, or if you send it with Python, we can tell the exact Unix time that we sent the request at to do it. And so, more or less, when we have this, because we changed it in the database, it should say invalid link, and we can check in our database right here. We can see that our values don't match up, right? We have a 1 and a 1, we have our random string, and we have our reset at, which is totally different values. So if we fix our reset at, it should still not work. Yep, perfect. So now if we want to break the odds a little bit, we can provide it a number like that, right? So we may be providing a value, and it may be trying to match that value, but obviously these two, OE31337 and OE12345, are obviously not the same. And if they were doing a strict comparison, then it wouldn't allow this. But since we're doing a loose comparison check with PHP, we're actually able to reset the password for the Nightbane user and log in successfully. So essentially what you'll want to do is you want to get the time. You'll update the time every time you send a request, but you can just keep iterating through until this matches with something that was generated in the database. Yeah. Any questions on that? Anybody want me to explain something a little better, dive a little further into something? Any of that?
So the main flaw in this code is just the loose comparison.
That's the main flaw, yes. The real second flaw is that they're basing it off of identifiable parameters, right? So typically you want to add one more, which is like a, more or less, yeah. Because even with the time, like the time will, even with the time specifically, like the loose comparison, this will never match. We can't get a time just on the Unix system because it calls current time. We won't, unless we go backwards in time, but we won't be able to call a time that has an OE in it, no matter what we do. So yeah, the big vulnerability here is the loose comparison on the user input pin, and then the reset password pin that's in the database.
Makes sense. Thank you.
Mm-hmm. Any other questions? Comments? Anybody lost? Go ahead.
So the pin variable,
Mm-hmm.
the loose comparison, was that accepted on the website because of the previously set pin code in the database, or was it just a loose comparison issue?
So it is both, right? We don't need to set the pin in the database. So what we would want to do as an attacker to limit our odds is we would basically brute force this endpoint. But every single time we would provide it this same pin, which matches any value similar to this. So all we need is a 5-digit pin that's numeric here, starting with the OE, which cuts our probability significantly, probably from 3.5 billion down to maybe a couple million, maybe 30 million possibilities. But essentially what we would want to do is we would re-roll the dice every time on this pin until we get one that will work that's similar to this. So I'll show it again here. Like, we just reset it twice. if we go reset the database, we didn't get a PIN that would work. So now that we know our PIN didn't work because we couldn't log in, we'd send another password reset request. And then we go check the database. Boom. And this PIN wouldn't work either. So we would just re-roll until we get a PIN that looks something like that. And then, you know, it's a possibility that that we can generate this. The cool part with this is it can be any 5 numbers here. It doesn't matter what it is. And then once we get that, hopefully that didn't save. We can still go back. I think it's saved. And essentially log in that way. So there's not a whole lot of luck involved, right? It's a little bit of luck and a little bit of brute force for this one.
Yeah, okay. Thank you.
Yep. Alrighty. Let's see if I had anything else.
Just another question for you.
Yep, go ahead.
So how do you determine the level of risk for this vulnerability? For just the general web app test?
Depends what the admin user can get access to, right? Usually the admin user has access to everything in the website. And so if you as a security researcher or as an attacker, if you can utilize that admin access to, let's say, grab all the customer data or, you know, get all the credit cards or even pop a reverse shell, right? A lot of features in the admin portal are unrestricted because it's already assumed that you understand the risks. You're the admin user. So, you know, if you get sort of like if you're having trouble because you can't upload a reverse shell to the website because it's blocking your reverse shells, the admin user may be able to, just because of some of the file restrictions on that. But that's pretty much how it goes there. It just depends, like the risk reward on that. It depends what you have access to. Getting access to any user on the tenant's information is already it's bad enough as it is, right? Because if we wanted the Pascal user, we still can't guess his password, but we can still log in as him. And we may be able to do things like, you know, if this was Amazon, if we could log into his Amazon account and send some packages to our house, that would be awesome. So, yeah, he's got a great password too. Yeah, does that answer your question?
Yeah, and I guess it also is dependent on other vulnerabilities you find that maybe you can change together, and like that makes it even more severe.
Absolutely. Yeah, you could own the entire system. You could own the entire cloud environment by chaining something together. But usually, if you can get the admin user on a web application, that's a huge step in terms of privileges. And it may not even be what you want, right? Depending on what your goal is, sometimes getting that admin user and having access to all that client data is all you want to do. It's too high of a risk, not a whole lot of reward if you try to privilege escalate up into the cloud environment. Once you're on the web app, and that's kind of where, the big thing in security is becoming web apps more than it is internal networks now, because you got to understand sort of the nature of how businesses are moving nowadays. There's not a whole lot of companies that are transitioning from the cloud back to an on-premise environment. It's almost non-existent, but companies are transitioning like wildfire from on-premise to cloud environments. And in doing so, the companies that stay on-prem usually have phenomenal network segmentation. So their web application, their databases, they're all segmented from each other. There's very little access in between them, and like getting in on the web app doesn't mean you're in on the internal network. And especially with cloud assets, pwning somebody's cloud environment doesn't mean you're going to pwn their Active Directory environment. It doesn't even correlate. But the thing with a web application, pretty much the goal of an attacker is to a lot of times get credit card information, to cause some sort of havoc on the company. And the web application is where all the data lives, right? It interacts directly with all your credit cards. It's how people log in to get their favorite movies. It's how they log in to get their purchase orders, how they log in to get their receipts, how they pay their bills. The web application is almost nowadays like the oracle of you know, users interacting with companies directly. I mean, you don't even have to call a company anymore nowadays. You just go onto their website, buy something, and it's in your, you know, it's in your driveway in 2 days. So yeah. All right. Strict comparison. So if they would have done a triple equals, it has to match exactly, whether that's strings, whether that's anything else. And this is a PHP specific thing. Last but not least, I know we're getting pretty close on time here. Knowing your tools. Ultimately, this is going to be like one of the most important things. And there's an old Abraham Lincoln quote that I still remember and say all the time. If you have 5 hours to chop down a tree, you should spend your first 3 sharpening your axe. And that's pretty much the same with any sort of pen testing or, you know, code development, whatever it may be. Understanding how to utilize your tools to the best they can be utilized, it's going to ultimately help you find better vulnerabilities, find vulnerabilities much faster, and have better vision on how the application as a whole works. So, all right. Yeah, that's pretty much all I had for today. I'm going to go ahead and stop the recording.